4.5, covalent compounds and their names. Covalent compounds, unlike ionic compounds, form when atoms share electrons rather than transferring of electrons that the ionic compounds do. They share electrons to complete octets. And this is going to happen between non-metal atoms. Notice, it's non-metal atoms that are going to share their electrons, forming a covalent bond. Hydrogen is an example of a non-metal. It has one valence electron. When you put the hydrogen atoms together, closer and closer as this chart shows, then they can each share their other hydrogen's electron between the two of them, and then it fulfills the duet rule, which is the rule that on the first period you can only have a maximum of 2 electrons there. Like helium, we know helium's a noble gas and it's very stable. So hydrogen will share a total of 2 electrons. Formation of octets, which is having 8 electrons total. Here's an example of fluorine. Let's see how many electrons it has to share. Well, fluorine, its valence electrons are 7. So we have an example of 2 fluorine atoms. If we put them closer together, then they share 1 electron from each one. So that means they have 1 pair of shared electrons. And when they do, they both then have 8 electrons that are around it, and it forms the octet rule, which is added stability, which means that it's going to form this single bond. And sometimes this line is written like this. It's not a subtraction. It represents a single bond, which is 2 electrons. So it's sharing 2 electrons. It forms a single bond. When you're writing an electron dot formula, you need to remember that we need to have 8 valence electrons around the central atom, unless, of course, it's hydrogen, because hydrogen can only hold a max of 2. So let's start with carbon. Carbon has its 4 valence electrons. If we were to say, let's make the formula for methane, CH4, well, carbon has its 4 valence electrons, hydrogen has its 1 valence electron. If we were to put it here, then hydrogen would be fine, but carbon would still need 3 more hydrogens. Why? Because it would need 3 more hydrogens with their 1 electron to form the stable octet rule, 8 valence electrons around carbon. Now, a double bond occurs when atoms share 2 pairs of electrons, and they do it if they don't have enough electrons to form the octet rule. And so a triple bond occurs when atoms need to share 3 pairs of electrons. So, guide to writing electron dot formulas. You're going to determine the arrangement of the atoms, determine the total number of valence electrons, attach each bonded atom to the central atom with at least a pair of electrons, place the remaining electrons around the outermost energy level until you use up your valence electrons. Then, if you need to make any double or single bonds to complete octets, you bring them in from the outside to share between the 2 atoms. So determine the arrangement of the atoms as you are getting ready to do your electron dot formula for carbon dioxide. Well, carbon is central to all living things. It's like in the middle of everything. So carbon, if you have carbon as a choice, carbon's always going to be in the middle. All right, now then we need to know how many total valence electrons we have. Oxygen has 6, look on the periodic table, and so we have 2 oxygens, so 6 times 2 is 12. Carbon has 4 valence electrons, so 12 plus 4 is 16. So we've got to remember that we're going to need to use 16 valence electrons. Electron dot formulas as we continue with our carbon dioxide. All right, when we then place a pair of electrons between our O and C, because we know we have to at least connect them with a single bond, that counts for 4 electrons. We need to get rid of the rest of the electrons that we counted up, the 16 electrons, so 16 minus 4 is 12, so we're going to start putting them around the outside until each obeys the octet rule. So 2, 4, 6, 8, 10, 12. Now then, let's count up to see if everything obeys the octet rule. Oxygen does, and this oxygen does, but this carbon only has 4. So because of that, we need to bring in pairs of electrons that are unshared from the outer atoms to then come in here to be shared. So you'll notice we need 2 of them, so that now this oxygen has 8, this oxygen has 8, and this carbon has 8. And it's represented with a pair of double bonds. Well, what happens if we need to do a triple bond? Well, nitrogen quite often has triple bonds. So nitrogen has 5 valence electrons. We put 2 nitrogen atoms together, and you will notice that to get a total of 8 valence electrons for each one, we're going to have to put a pair here and a pair from here to make a total of 8 valence electrons around each nitrogen. And so we have ourselves a triple bond. All right, so let's see how we're going to name our covalent compounds, which, by the way, it's much easier than naming ionic compounds. In naming covalent compounds, you name the first nonmetal by its name. And then the second one, you're going to change the ending to "ide." That's it. You do have to use the prefixes, though, which is different than for the ionic. You didn't have to say the prefixes. You must say the prefixes for covalent compounds. Why? Because with covalent compounds, there can be more than one way that they're going to connect together with nonmetal, with the 2 nonmetals. So we name the first nonmetal by its name, name the second one by using the first syllable followed by "ide," and add the prefixes to indicate how many subscript atoms there are. Here are some prefixes that you need to know how to use. Name the covalent compound NCl3. So the first one is nitrogen, and we have chlorine for the second one, but because the second one is the ending, we're going to change the ending to "ide." So we're going to have a nitrogen and chloride, but we can't just say nitrogen chloride. Why? Because this is a covalent compound, and nitrogen can form different combinations with our chloride ion. So we have to say which one it is. So it's nitrogen trichloride. Here are some other examples of common covalent compounds. Press pause and please look at these and how they're named. All right, so press pause now and see if you can figure out the name for these compounds now that you know the rules. Silicon tetrachloride. Because our silicon only has 1, we don't need to use mono with silicon because it is the first atom. We're only going to use mono if it's represented on the second atom. Now then, on this phosphorus, we have 2. So diphosphorus, we have 5 oxygens, pentoxide. Now, you might think that chlorine should be called chloride, but no, only if it's at the end. Notice here at the beginning, we're going to say dichlorine heptoxide. Press pause and see if you can do these namings. All right, step 1. We have carbon and we have oxygen. B, we have nitrogen. We also have oxygen. We have phosphorus for C and fluorine, and we have carbon and we have chlorine. So we change the second one endings to "ide," as in oxide, fluoride, chloride. We're not done yet. We now have to use the prefixes. So we have carbon, and we only have 1 oxygen, so we must say carbon monoxide. Nitrogen dioxide. Phosphorus trifluoride. Carbon tetrachloride. Well, what if we are given the name of the covalent compounds and we need to then write it? Well, that's even easier. We just write the symbols in the order of the element's name and then write any prefixes as subscripts. So diboron trioxide. Well, we have boron and we have 2 of them. We have oxygen and we have 3 of them. So diboron trioxide. Press pause and write the correct formula for each of the following. You will notice that we have phosphorus and we have chlorine, and we have nitrogen, we have oxygen, we have sulfur, and we have fluorine. Now then, the prefixes, penta means 5, so phosphorus pentachloride. Di means 2, so dinitrogen trioxide. Sulfur hexafluoride, we have sulfur and 6 fluorides. Well, here's a summary now to naming all of our compounds. In the last sections, we had this divided into, we were learning about ionic naming. So you will notice how to go about the ionic naming. That's when the metal was first, or ammonium, because it's an ion. And we just in this section learned about covalent naming. That's when you have only 2 nonmetals. So this is a nice summary. All right, on this learning check for our last thing, let's go ahead and figure out how to name these. But in order to figure out how to name these, we have to first determine which set of rules. Is it ionic or covalent? So on A, S, sulfur, is a nonmetal, so we're going to name this covalent naming. So sulfur trioxide. B, barium is a metal, so it's ionic naming. We don't name the little subscripts. Barium chloride. C, we have this ion that we memorized, ammonium ion. So if it's an ion, it's going to be named like an ionic compound that it is. So here's our ammonium, and this PO3 is like phosphate, which was PO4. However, it's one less oxygen than phosphate, so we know it's ammonium phosphite. Here we have copper, which we know copper is a metal, but we also know it can be more than one metal. So we have to remember that we got to use Roman numerals. It can be more than one charge, so we have to figure out, by looking at the partner CO3, which is our carbonate, it's a -2 charge. So that means we need an overall +2 charge. So 2 times what number is a +2? Well, we know that number's 1. So this name is going to be copper 1 carbonate. We have nitrogen first. Nitrogen is a nonmetal, so dinitrogen tetroxide, as you see as we're looking at this.